Buenos dias. Good afternoon. Thank you for the opportunity to speak to you today about tunnel fire protection, regulations, standards, and guidelines for structural fire protection for road tunnels. Over 30 countries have adopted regulations to establish requirements for fire protection, life safety, and operational safety within their road tunnels. In addition to these regulations, there are several recognized standards and guidelines that have been published by organizations such as the World Road Association's PIROC, International Tunneling Association, ITA, through European directives, and the National Fire Protection Association, NFPA 502. These are all specific to fire protection, life safety, and operational practices of road tunnels. These existing international regulations, standards, and guidelines often differ from each other in their requirements. These differences are generally due in part to operational experience, local conditions, vehicle fleet mix, emergency response capability, and/or technical philosophies. None of these are incorrect. The numerous documents relating to road tunnel fire protection and life safety that exist today differ by intended purpose and authoritative stature. These documents can be classified and defined as follows. Regulation is a document containing specific mandatory requirement adopted and enforced by a legal government entity. A standard is a document containing mandatory language, usually produced by a technical entity such as an association or society. These documents by themselves have no legal standing except where they have been adopted by on the behalf of a government agency or legislative action or other legal empowerment or authority. A guideline is a document providing recommended practices in the design, construction, installation, and/or operation of life safety, security, and/or fire protection system for road tunnel applications. These documents are typically prepared by technical associations as well as by government agencies. Between 1999 and 2001, 3 catastrophic fires occurred within the European road tunnels that collectively accounted for 62 fatalities, destroyed 91 vehicles, and caused serious damage to more than 2,100 meters of tunnel structure. These significant fires occurred in the Mont Blanc, the Taran, and the St. Gothard road tunnels, highlighted the fact that large-scale fires in tunnels are not necessarily limited to hazardous or otherwise regulated cargoes, and more important, that accepted fire protection and life safety design assumptions and practices in place at that time was not sufficient. It became obvious that each road tunnel is a unique facility due to numerous variables, and that these variables must be taken into account in order to better understand the equally unique risk potential for that facility. In the aftermath of these events, the European Union commissioned several research programs to improve road tunnel safety. In 2004, they issued a directive, 2004, in establishing regulatory legislation for minimum operation and safety standards. The National Fire Protection Association, NFPA 502, issues codes, standards, recommended practices, and guides which are developed through consensus process approved by the American Standards Institute. NFPA 502 standard establishes minimum fire protection and life safety requirements for road tunnels, bridges, and other limited access highways, where access by emergency responders is physically limited. NFPA 502 has generally been adopted throughout North America by authorities concerned with road tunnels. NFPA 502 Technical Committee is represented from 8 different countries, balanced by various interests such as special experts, manufacturers, users, research and testing, enforcement, and consumers. In 1999, PIROC published a technical guideline entitled Fire and Smoke Control in Road Tunnels. The guideline was prepared by the PIROC Technical Committee in an effort to present a state-of-the-art assessment of the issues, methodologies for evaluating fire and smoke control in roadway tunnels. It was intended for those interested in roadway tunnel planning, designing, construction, operation, and safety, including owners, consultants, operators, researchers, regulators, and emergency responders. This ITA guideline is to provide recommendations for the design of road tunnel structures for safe operation. These guidelines take into consideration the time temperature curves as recommended by PIROC and developed suitable means and methods for the protection of the structures from collapse during a fire event. Guidelines also reference time and heat release rate curves generated from the full-scale fire test in Runehammer, Norway, or the RWS fire curve. These are several different fire curves that are recognized and used for tunnel fires around the world. The RWS is the red line here, which was developed in the Runehammer test and is specifically used in Netherlands and the US. The hydrocarbon Eurocode is green line. The modified hydrocarbon curve is a French fire curve. The ZVT, or the RABT, is a Germany fire curve. And then, of course, the ISO curve, which is a general building fire curve. As you can notice, all of the tunnel fire curves has one thing in common, that there is a very large thermal shock in the first 5 to 10 minutes of the fire event. PIROC proposed guidelines for design criteria makes a distinction according to the type of traffic, which consequently the possible fire load, and consequences of a structural failure due to fire. For example, submerged tunnel or tunnel in unstable ground. Immersed tunnels and tunnels in unstable ground minimum guideline is ISO 60 minutes to RWS or hydrocarbon 120 minutes, and possibly up to 180 minutes of duration for trucks and tankers. Tunnel in stable ground, minimum guideline is the ISO 60 minute to no protection pending upon the repair cost after the fire event. ITA proposed guidelines are broken into road tunnel categories. Category 1 is a passenger vehicles, light vans, and pickups. Category 2 is heavy goods vehicles, including straight and trailer trucks, petrol tankers, and other flammable hazardous materials. Immersed tunnels in unstable ground has a minimum guideline of ISO 60 minutes to RWS, 2 hours to 3 hours. Tunnels in stable ground and cut and cover, minimum guideline is ISO 60 minutes to no protection, pending upon, once again, the repair costs of the fire event. NFPA 502, edition 2014, states regardless of the tunnel length, acceptable means shall be included with the design of the tunnel to protect all primary structural concrete, steel elements accordance with the standard in order to support the firefighters' accessibility, mitigate structural damage and prevent progressive structural collapse, and minimize economic impact. It goes on to say that the structure shall be capable of withstanding the temperature exposure represented by the RWS time temperature curve or other recognized standard temperature curve that is acceptable to the authority having jurisdiction, followed with an engineering analysis. During a 120-minute period of fire exposure, tunnels with concrete structural elements shall be designed or protected such that the fire-induced progressive spalling is prevented. Once again, here is that same graph, and the red line is the RWS time temperature curve. NFPA 502 provides specific criteria for structural fire protection materials. For tunnels with cast in situ concrete structural elements, the temperature of concrete surface shall not exceed 380 degrees C. Precast concrete is protected such that fire-induced progressive spalling is prevented. The temperature of the reinforcement steel within the concrete shall not exceed 250 degrees C, assuming a depth of 25 millimeters from the concrete surface. It also says fire protection material shall be non-combustible in accordance to ASTM E136 or equal. And also it says the fire protection material shall have a minimum melting temperature of 1350 degrees C. The material also shall meet the fire protection requirements with less than 5% humidity by weight and also fully saturated. The following are some photographs of some USA projects that has been protected or upgraded to NFPA 502 during the last 8 years. This particular project was in Fall River, Massachusetts. The highway structure was underneath the government center, and which was a critical infrastructure to protect in case of a fire event. The fire protection the fire protection boards was placed on galvanized steel framework suspended from the existing ceiling. This was the finished product here. This was the Port of Miami tunnel in Miami, Florida. It was a new tunnel construction by a tunnel bore machine underneath the shipping channel from the MacArthur Boulevard going to South Beach to the Port of Miami. The fireboards were selected and anchored in a faceted method, a series of tangents around the circular tunnel. The Port of Miami tunnel also chose to have a top coating, and this was for aesthetics and the ease of cleaning the lining. The final photograph shows all the mechanical and the jet fans and the lighting, which was also coated with this top coating. This here is a architectural lining. This specifically was a aluminum lining. This is the new Midtown Tunnel in Norfolk, Virginia. It's an immersed element. It is protected to NFPA 502/2011. It was protected by the use of the lost formwork method of installation, where the fire protection boards are laid on top of the concrete form. Stainless steel screws are inserted onto the backside, and then the concrete is poured. When the forms are relieved, when the forms are released, the fire protection is in place. This photograph is of the downtown tunnels in Norfolk on the same project, and these were built in 1960, and they were upgraded to NFPA 502/2011. The fire protection that was selected was boards in a double layer, post-curved and post-fixed to the concrete structure. This is another tunnel in New York City. This was the Queens Midtown Tunnel. This was flooded during the Hurricane Sandy and is being currently upgraded to NFPA 502/2011. This project is a Metropolitan Transit Authority project in New York City. The owner wanted to protect the divider deck that separates the roadway and the ventilation plenum, where you can, these are the ventilation ports, to keep the slab from progressively collapsing during an RWS fire event. Once again, for ease of cleaning, they actually looked at four different colors to paint the boards, and they chose the dark gray. And this is the neighbor tunnel to this tunnel. It's the Brooklyn Battery Tunnel. It was built in 1950, and this tunnel also was flooded by Hurricane Sandy. Once again, it's a Metropolitan Transit Authority, and like the Queens Midtown Tunnel, they wanted to protect the divider slab separating the ventilation plenum and the roadway. And they also has chose the dark ceramic coat for the color and maintenance. One other mention is that another type of fire protection, of course, is spray. A spray fire protection coating. It can be robotically applied or manually applied, and has also been globally tested and used around the country, world. Thank you for your attention and questions.